We'll discuss some typical Tcas display elements and operational techniques. When you are done with this lesson, you will be able to understand Tcas symbology and how to react during a Tcas event. Tcas is an aircraft-based collision reduction system. The impetus for development of Tcas was the collision of a TWA superconstellation and United Airlines DC-7 over the Grand Canyon in 1956. At the time of this accident, the Big Sky concept led most safety experts to believe that a mid-air accident was almost impossible. The Grand Canyon accident, which occurred in an area with no ATC radar services, galvanized ICAO and the FAA to begin research on an airborne system to reduce the risk of mid-air collision. Full implementation of Tcas went into effect on December 31, 1993. Tcas 1 initially produced traffic displays and a traffic advisory alert. The current generation, Tcas 2, adds a coordinated resolution advisory function that gives crews escape maneuver guidance. Although Tcas was initially required to be included on all aircraft with more than 30 seats, ICAO eventually extended the rule to include any aircraft with more than 19. Implementation of Tcas has been a success, reducing the rate of collisions, with most notable mid-air incidents occurring due to misuse of the system. Tcas operates as a function of the aircraft's transponder radios. Each Tcas-equipped aircraft will send out an interrogation signal. In turn, each aircraft that is interrogated will send a response signal. When responses are received, the Tcas system will then calculate the following. Range, based on interrogation response round-trip time. Bearing, by the directional antenna from the response. And altitude, as reported by the aircraft. As each aircraft transponder interrogates others and gives out its own data, the system can build a 3D map of the surrounding airspace and traffic within it. This information is used to create a traffic display and two types of traffic alerts: traffic advisories, or TAs, and resolution advisories, or RAs. While most aircraft will differ, this topic discusses some more common controls for the Tcas system. For specific aircraft configuration and information, consult your company's manuals. Tcas control is normally accomplished on the transponder panel. A mode selector switch, or selection, is used to set the operating mode for the Tcas and transponder radio. Typical mode settings include standby, transponder, TA only, and TA-RA. Visual data from the Tcas can be presented digitally in a variety of ways, but can be divided into two types: traffic display and resolution advisory display. If any mode other than TA only or TA-RA is selected, the Tcas functions will not operate. When the switch is in the TA only or TA-RA position, Tcas is operational. TA-RA is the normal operating mode for the Tcas. When this mode is selected, the system provides the pilots with traffic information and both types of advisories. In the TA-only mode, the resolution advisory function of the system is selected off. TA-only is most commonly used during engine-out operations, when a commanded RA may exceed the reduced performance of the aircraft. Normally, traffic is displayed in a range from 2,700 feet above to 2,700 feet below the aircraft. Most aircraft Tcas systems will include an above or below control. This allows the crew to select an increased range either above or below the aircraft. When set to above, traffic is displayed from 2,700 feet below to 7,000 feet above the aircraft. When set to below, traffic is displayed from 2,700 feet above to 7,000 feet below the aircraft. This altitude range function gives the flight crew greater ability to see potential traffic during the climb or descent phases. Tcas traffic and status are displayed on each pilot's primary navigation display. For some aircraft, this display may be included on an integrated vertical speed indicator or IVSI. Varying range selections on the ND will allow a scaled display of the traffic. Most aircraft systems allow the crew to toggle Tcas display on and off. In addition, some aircraft may feature a pop-up Tcas display feature that automatically displays Tcas data during a TA or RA condition. The Tcas display uses 4 different symbols to show traffic, depending upon its threat level. Target types include non-threat traffic, proximate traffic, traffic advisory, and resolution advisory. The threat level of the traffic is determined by its location, relative altitude, and closure rate. Non-threat traffic is not currently calculated to be a threat to your aircraft. The Tcas displays these targets within the selected area to enhance the flight crew's situational awareness. These targets are normally shown as a white or cyan hollow diamond. Proximate traffic indicates a target that is operating in a close proximity to your aircraft, but its closure rate still indicates it is not a collision threat. It is displayed as a solid white or cyan diamond. TA and RA traffic are depicted as solid amber circles and red squares, respectively. These will be discussed further in another topic. Each target symbol displays vertical information about that aircraft. This information includes current altitude and vertical trend. Traffic altitude can usually be displayed relative to your altitude or as an absolute altitude. When relative altitude is selected, the value displayed is in hundreds of feet above or below your aircraft. A plus or minus sign indicates if the target is above or below your altitude. In the example, one target is 1,000 feet above, while the other is 500 feet below. A Tcas target with 00 displayed indicates the aircraft is at the same altitude. If the altitude separation is unknown, no relative altitude is displayed next to the target. If a Tcas target is climbing or descending at a rate of 500 feet per minute or greater, an up or down arrow is displayed to indicate a climb or descent. If the target is level, no arrow is displayed. Tcas traffic alerts provide aural and visual indications when a collision hazard exists. In the event of a resolution advisory, Mode S transponders are programmed to communicate and coordinate escape maneuvers to maximize safety. For example, if two aircraft approach at the same altitude, the Tcas systems will command one aircraft to climb and one to descend. This system is more accurate and has a faster reaction time than ATC radar. For this reason, during a Tcas alert, aircraft should follow RA commands and disregard ATC instructions if they conflict with Tcas. A traffic advisory alerts the flight crew when an intruding aircraft's closure rate becomes a threat but doesn't require any evasive action from the flight crew. Although not in itself an impending collision hazard, a TA alerts pilots to a potential loss in traffic separation. The Tcas generates a traffic advisory based on the two aircraft's rate of closure. At approximately 40 seconds from the predicted point of least separation, a TA is generated. To highlight this conflict, TA targets are displayed as a solid amber circle and accompanied by an aural alert.
Traffic, traffic.
This alert sounds once and is then reset. A resolution advisory highlights traffic that is an immediate threat within approximately 25 seconds from the closest point of approach. RA aircraft are depicted with a red square on the Tcas display. In addition, visual and aural advisories are provided to increase or maintain vertical separation from the intruder. In this example, traffic is 2 nautical miles away, level with your aircraft, and descending. The following aural alert is heard.
Climb, climb.
During an RA, the VSI displays colored green and red bands on the scale. The green fly-to band designates the safe vertical rate which the pilot must fly to ensure proper separation. The red band indicates the vertical speed to avoid. Proper traffic separation assumes that the crew promptly and swiftly adjusts aircraft pitch and power to maintain the green band on the VSI. If maneuvering is required, disengage the autopilot and smoothly adjust pitch and thrust to achieve and maintain the vertical guidance indicated by the green band on the VSI. As an RA encounter progresses, the Tcas system may provide changing guidance depending on how the other aircraft is reacting. In some instances, additional climb or descent rate is required.
Increase climb, increase climb.
Or, the Tcas will require a change in direction. In our example, the intruder aircraft is now climbing, so our Tcas instructs a descent.
Descend, descend now, descend, descend now.
When separation from the other aircraft is increasing and Tcas predicts no further advisories, the alert "Clear of conflict" sounds.
Clear of conflict.
To prevent unwanted alerts, the Tcas is usually inhibited at low altitudes and during higher priority warnings. At low altitudes, RAs are inhibited to prevent descend advisories that conflict with terrain. Inhibiting Tcas during higher priority warnings, such as engine fire, allow the crew to focus on one emergency without distraction. All EGPWS and wind shear warnings have priority over Tcas alerts.